today's learning goal. I can identify solutions of inequalities in one variable. So in other words, what does that solution say? What does it mean? What does it tell me? And then I can write and graph inequalities in one variable. Now oftentimes, I don't know why, I just have this crazy feeling that this should be easier than students seem to make it. I don't know just what it is about inequalities. I think one of the things, first of all, is making sure that we understand the inequality symbols. So we're going to start with an inequality. First of all, the definition for an inequality is a statement that compares two expressions. What's happening in an equation? Are there also two expressions? Yes or no? What do you think? One side of the equation, the other side of the equation. Are they expressions?
Yes.
Yes, we have expressions set equal to each other in an equation. In an inequality, we have to compare them with something other than an equal side. In other words, one expression is really not equivalent to the other expression. So then how can we compare them? So an inequality compares two expressions by using one of the 5 symbols. So what does this symbol, pointing to the left, what are the words that you would say as you're reading that? Josh?
Less than.
Okay, less than means we should subtract. Remember, 3 less than x means take 3 away from x. Is that probably when you did your reading in your lesson? Is that what they said that symbol stands for? Okay, what is it?
Something like it's less than.
Is less than. That word is really important there, okay? So, is less than. If we just have less than in our statement, we are saying we're supposed to do a subtraction. But if we are saying the is less than, now we're making a comparison. Now we're saying this is being compared to another, and it is supposed to be less than. Okay, so then what happens when we stick that little line segment underneath it?
Less than.
What did you say, Austin?
Less than or equal to.
Well, no. Is less than or equal to, yeah. I'm going to be really fussy about this. Is less than or equal to. So what do they mean by that? What does that mean? Is less than or equal to, Devin?
But it can't be any more than a certain number.
Okay, it can't be any more than a certain number. Can it be that certain number?
Yeah.
But it can also be that certain number. So it has 2 choices. It can be the number that it is. So in other words, that meets the equal to part, but then it also has to be less than, or like you said, it can't be any more than that number that it can be equal to. Okay, well then this one is what? What's this one then?
Is greater.
Is greater than. You guys are catching on. Is greater than, because greater than would mean what? Bigger, which would mean what operation? No. Addition. Greater than, more than. Those mean add, but as soon as we put the word is in front of it, is greater than, now we are making a comparison, okay? And the next one, class, is?
Is greater than or equal to.
Is greater than or equal to. Okay, I'm going to state this and I mean it. I really, really mean this. I don't mean it just for my class this year in algebra, but I mean it for every other math class that you are going to take. You need to know these symbols like you know the equal sign. You should be able to be so fluent in them that you can, as soon as you see them, without stammering, without not sure if you're right or not, you should be able to say, this is what it says. So if you don't, when you look at those symbols and you cannot read these words like we just wrote, you better start working on that. You need to be able to. If I write 3 equals 6 over 2, you have no problem reading the equal sign, do you? You can read that very easily. 3 equals 6 over 2. You don't even have to think. I'm guessing, right? If you see the equal sign, can you say equal to right away? Is equal to? Yeah. But it's amazing how many times when students are expected to tell me what these say, that they're like, is greater than? Is less than. And then they wait for me to see what the expression on my face is going to be to see which one might be the right guess. So that isn't how we should be able to handle these. We got to know them, Okay, very important. And then what's this one say?
Is not equal.
Yeah, is not equal to. The fifth inequality symbol is not equal to. When we are making a comparison of numbers that are not equal to each other, but we're not comparing them. All we're saying is, you know what? They're not equal to each other, therefore this is a false statement, okay? So a solution of an inequality. Well, a solution of an inequality is no different than a solution of an equation. What do solutions have to do for the statement? Make them true. They have to make it true. So a solution of an inequality has to make the statement true. Well, then what is the difference between getting a solution for an equation and getting a solution for an inequality? What's the difference?
Solution makes it true, but for an equation, it would be like an answer.
Okay, so there is no answer for inequalities.
It's like what makes it true.
It's what makes it true. So what's usually the case when we're solving an equation? There's how many values, how many real numbers make the equation true? Typically. Just one, right? Just one, typically. That doesn't mean that's always the case. There are times that when we are solving equations, and it will happen this year, when we're solving equations, that we will get more than one solution for the variable. But typically, we just get one solution. When we are solving an inequality, is there only typically one number that will satisfy that solution? No, there's a range of values, isn't there? There's from what we call the endpoint, I call it the endpoint, different books call it different things, the significant point, there's all kinds of, I just call it the endpoint. It's like from where it starts and all the numbers that satisfy the inequality. So there's how many solutions to an inequality? Really? An infinite number. Yeah, there's an infinite number. Okay, so describe the values for the variable that make the inequality true and show the solution on a number line. Okay, I need you to really tune in here because I don't think you're going to want to always have to make such detailed number lines, right? Can we begin to show the whole number line? Can we even begin to draw the whole number line and detail it, label it? No, we can't. It goes on forever in the negative direction, it goes on forever in the positive direction. So in reality, what we're getting is a snapshot of the number line. It's kind of like saying, if I tell you where I live in Valley City, I'm giving you a snap, it's just a part of Valley City. It's just a certain area. And so when we are talking about the number line, we have to focus in on where on the number line are we taking a snapshot, a little picture of. So I'm not going to make you make them as detailed as they do, but I do need you to tune in and hear how I do want you to do them, okay? So first of all, describe the values for the variable that make this inequality true. X would be,
Anything less than 10.
it's standing in for any real number, right? So we're going to say all real numbers. But right now we're not saying the whole number line, but we are saying from the number line, by stating all real numbers, from the number line, all real numbers less than 10. Now notice we didn't use the word is there, did we? Because we're not reading the statement, we're reading, if we read it as it's stated, we would say X is less than 10. So all real numbers less than 10 satisfy. Okay, so when it says we're also supposed to show that on a number line, so here's how we're going to do it. Our end point, our significant point, the 10, we're going to stick it kind of like in the middle. Maybe sometimes it'll be somewhere else. I want to see the integer neighbors in the positive direction and in the negative direction. I want to see the immediate neighbors called integers. What are the integers again? Numbers. What kind of numbers? The counting numbers, but also some more. Not just the counting numbers. What is the counting number set, by the way? 1, 2, 3. It starts at 1 and goes up by ones, right? Okay, well that's not just the integers. The counting numbers do not get to be the only qualifiers as integers. What happens when we add 0 to the counting number set? What set does it become? Anybody know? For Friday prize, what does, when you add 0 to the counting number set, what number set do we now have? 10. 5, 4, 3, 2, 1, 0. Time's up. The whole number set. Okay, now, how do we define the integer number set? All the whole numbers and their opposites. Oh, those are the integers. So, not only 0, 1, 2, 3, 4, 5, but -1, -2, -3, -4, and so on, right? So, when I say integers, you better be able to picture that we are talking about the whole numbers on the number line and their opposites. So, when I say I want integer neighbors, who would be the integer neighbor going in the negative direction? 9. Yeah. Doesn't have to be negative, just going in the negative direction. And then equal distance away on the other side. Show me good number line sense. Equal, well, that's close. That's pretty good. I've run top of it here. Equal distance away going in the positive direction is 11. So that's the only, I'm not going to make you show any more tick marks, okay? So right now we are not even graphing. We are not graphing right now. We are getting our number line set up. We're taking a picture of where do we want to be on the number line. Is 10 included in this solution set? It says all real numbers less than 10. So it's not included, is it? 10 is not in this solution set. So how do we show that 10 is not included?
Just a circle.
Just a circle. We do not shade it in, do we? We do not shade it in. 10 is not included. So we leave an open circle there. But then we need to show all the numbers less than 10. So how do we do that?
Arrow.
We shade going, yeah, so we shade going this way. This is how I do it. I shade, make this so I can see, and then I take my arrow at the end and also shade that and make it bigger. All numbers less than 10. 10 not included. So is the first solution in this one 9? Is that what that means then?
Yes.
Think carefully here. Is 9 the first solution? Put that chair. Well, let's see if it works. Is 9 less than 10?
Yes.
Okay. Well, are there any other numbers between 9 and 10 that are also less than 10?
Yes.
Like, give me an example. 9.5. So anything up to 10, well, we could go 9.9999999, we could say 9's forever. That one is less than 10. Okay? So it isn't just the integers. We were just using integer neighbors to show a good picture of the number line. So I don't want you to be confused there. We just want to be able to show where we're at on the number line. Questions, anyone? So what would we say for this one? What does this solution set say?
Y is greater than or equal to 3.
Yeah, so y is greater than or equal to -3. So y is really representing what? All real numbers. The numbers on the number line that are greater than or equal to, right? So in your homework, when they're asking you to describe the solution set, this is how we should be doing it. Well, then we're going to graph it. We're going to show what does that look like on the graph. Okay, so what's our important point, our end point? -3. So we just go -3, okay? Integer neighbor heading in the negative direction.
-4.
-4. Integer neighbor headed in the positive direction. -2. Is -3 included in the solution set? So what do we do when it is? We shade in the circle that we put there. Make sure that you and I both can see very clearly on your number line what is in the solution set. And which direction are the numbers greater than -3? To the right, going in the positive direction. So from our number line, if we would put -3 in for y, does -3 satisfy the statement?
Yeah,
What part of it?
equal to.
The equal to part. Well, let's look at our integer neighbor here, -2, that is in the shaded part. Does -2 satisfy if we put it in for y? Does -2 satisfy the statement? Is -2, what part of it does it satisfy?
Yes.
The is greater than? Is -2 greater than -3?
Yes.
Yes, it is, isn't it? Okay. How about this next one? What's that say?
-3/4 less than.
Okay, -3/4 is less than m. Well, that seems kind of backwards, doesn't it? Is there another way to write that so that the m, the all real numbers part, could be on the other side? Is it like an equation they could just trade sides? But what else?
You have to change the sign.
You gotta switch the sign if you do that. So if we're gonna do that, we could say m and -3/4 are gonna trade places, but then it doesn't stay is less than, it becomes is greater than. Now, in my world anyway, I don't know about yours, but in my world anyway, it seems to work better for me when the variable is on the left side of the inequality rather than the right side. This one says -3/4 has to be less than all the real numbers m can be. -3/4 is less than all the real numbers m can be. Well, this one says all the real numbers greater than -3/4 are what m can be. So I'm just thinking that one might be a little easier to state. All real numbers greater than -3/4. Because is -3/4 included in the solution set? No, it's not. Okay, so now this is where you really need to pay attention, okay? -3/4 is our endpoint. We need it. We need it represented, okay? So -3/4. But we're going to do integer neighbors, not 2/4 and 4/4. We're going to do integer neighbors. So who is the integer neighbor to -3/4 in the negative direction? -1. Who is the integer neighbor headed in the positive direction? 0. 0. Now, which one's it closer to? Is it exactly halfway between? No. So we have to show better number line sense by, instead of saying, oh, I can just go like this again. No, I can't. I can't do that. I have to make sure that I judge accordingly where it is. So we have -1. Which one is it closer to?
-1.
It's closer to -1, isn't it?
Yes.
And then we need 3 of those sections on the other side, don't we, to get to 0? So this is a distance of 1/4. We need a distance of 3/4 to get to 0. So 1, 2, I would be about right here, wouldn't we? I was just putting tick marks in there so that I could kind of get a good judge of where I should be. They don't have to be there. So show me good number line sense. You don't show me good number line sense, I'm going to be like, oh, bad number line, check. I'm going to have to count this wrong. Is -3/4 included?
No,
No, so what do we do?
just a circle.
Open circle. Which way are we going to shade?
Right.
To the right. We're going to go towards 0. And then we're going to use 0 to see if it makes the statement true even before we switched it over. Is -3/4 less than 0?
Yes.
Yeah. Is
0.
greater than -3/4? Thank you very much. Is 0 greater than -3/4?
Yes.
Yes, it is. Okay. So I know you probably feel like I'm beating this to death, but every time I think this should be easy for students, they prove me otherwise. Have you had a lot of work with inequalities before you got here? You have, but not the rest of you? Not so much? Okay, let's go to the back side. Okay, everybody's book open to page 103. Let's open to page 103, it says. So the first thing we're going to do is we are going to recreate these number lines We're doing number 10, starting at number 10, but we're not gonna make them as detailed as they are because we're lazier than that. So we're going to do this. So in your homework, I expect the same thing. I wanna see what your inequality statement is representing, what solution, because this is the solution shown on the number line. So we're gonna show the -2 and the -3 and the -1. Remember the integer neighbors. That's the only part I'm gonna make you show. And there's a closed circle at that -2, a filled in circle, and it's shaded to the left in the negative direction. Well, the solution region, the shaded region, is what the variable represents. So we get to pick our own variable, so pick a variable.
X.
X, okay. So what does this say? X has to be what?
Less than or equal to.
Less than or equal to -2. Did I write the correct statement?
Yes.
Correct symbol?
Yes.
Okay. Okay, why don't you go, let's just go right now and would you just recreate all of these on your paper? Just get the graphs for right now. And then once you have all the graphs made, then maybe start going and naming them and we'll run through them. If you want to go and make them as detailed as they do, that's your call, but this is the minimum of what you do, okay? And then once you have all of your number lines shown, the solution given in its number line form, then give the solution in its algebraic form. It's the algebraic statement you can make representing that. And as we finish, if you're finished up, you can come up, as you finish up, you can come up and answer one of those up there. I want 5 different volunteers. So writing the algebraic inequality statement. Head up. When your notes are done, go answer one. Everybody, 5 of you, different guys.
Let's erase it.
With the
Erase tool.
Yeah, with the erase tool, that would be a good spot. There you go. Oh, sorry. know, do you?
Yeah.
Did I make any of my number lines wrong, by the way, we compare? Did I copy them from the book correctly? Couple more. Okay, one left, different individual than one of the four who's been up there already. We got away with it, the pen didn't skip that time. Okay. Any challenges? Any challenges on any of these? You disagree with any of them, Devin?
Number 11.
Number 11, what do you want to do to number 11? What do you think is wrong?
Should just be 1/2. That's it.
Oh, it isn't just -8, it's -8.5, okay. Any others that we need to challenge? So we got this? Okay, good job. Okay, then let's move on to the last thing that we're going to practice together here. Define a variable and write an inequality for each situation and graph it. So it looks like we're jumping now to number 16. There must be at least 20 club members present in order to hold a meeting. Well, guess what I'm going to insist you do when you pick a variable for an unknown in an application problem, in a word problem. Explain it. So, what variable do you want?
P,
P. Okay. P is what?
the number of members present.
Oh, it's, yeah. Is members, number of members present. Okay, so get my number in there. Is number of members present. And it's important that we have that word present in there because it isn't just the members, it's how many members are actually there, present. Okay, it says there must be at least 20 club members present in order to hold a meeting. So either you graph it first and then write the algebraic statement, or you write the algebraic statement and then graph it, whichever works best for you. So go ahead, try it. What do you think what do you think could represent this situation? There must be at least 20 club members present. Okay, who wants to tell me what to write to finish my algebraic statement? AJ?
P is greater than or equal to 1.
At least 20, so that means there should be 20 or more. Is greater than or equal to 20, does that say at least? Does, okay. And then on the number line, the 20 would be shaded in because 20 members counts as enough to hold a meeting, and which way do we shade?
Right.
To the right. Okay, now, there are some restrictions on here. And we have to, right away from the beginning, even if the book did not do this, we're going to learn how to do it right away from the beginning. What can't P be, or what does P get restricted to be, considering that it's club members? Shade? No, it's, okay, so look at our region here. We got 20 on up. Would 20 and a half count?
No.
No. So we need, so what we're going to say here is where P is a, what kind of a number? Whole number. We got to have whole numbers of people. So even though the shaded region shows anything bigger than 20, including 20 itself, there are a whole bunch of numbers in between those integers that it can't be, it has to be a whole person, okay? Okay, let's look at number 17. A trainer advises an athlete to keep his heart rate under 140 beats per minute. What's the unknown in this one? Kevin?
The heartbeat per minute.
So I think we already know that. It says under 140 beats per minute.
That's the most you go up to.
Okay, so we're talking about the what then? What can change in this situation? Just like in that one, the number of members present could change, right? What can change in number 17?
Number of beats per minute below one.
So can we just call that heart rate? Your heart rate, and it is measured in beats per minute, you're right. So let's put that, what do you want, what variable did you pick, Devin? Did you pick one?
I didn't pick
Oh, pick one for me.
You do X.
X, okay, X is the heart rate in BPM, beats per minute. Okay, well, it says an athlete is to keep his heart rate under 140 beats per minute. So can it be 140?
No.
No. Should it be less or more?
Less.
Less. Under says less, so is less than 140. Okay, and then let's show that on the number line. 140, 141, 139. Less than, but not including, so open circle, shaded to the left. Oh, think there's any restrictions on this one? Can you have part of a heartbeat?
No.
Why not? You see your heart can't beat at like 63 and a half beats per minute?
Yeah.
Why can't it?
Well, yeah,
I bet it could. But what can't it do?
Half a beat.
It can go a half a beat, it can go a third of a beat, it can go a tenth of a beat. What can't it do? If you're gonna be alive.
Not
It
Zero.
can't be negative, it can't be zero, right? So we're gonna have to say where X is what? What kind of a number? A positive number, yeah. Where X is a positive number. We can't have a negative heartbeat, we can't have a zero heartbeat, or you're dead. Okay. So not only do we do this, but we also think about what they're representing. We look at our description, we say, oh, what can it be, what are the restrictions? So make sure you write down the assignment that you have carefully.